Today we're going to look at how to use U-substitution to solve indefinite integrals. So say we have the integral of e to the x squared times x dx. With U-substitution, we want to set one part of our integral equal to u, and then find the derivative of that. What I'm going to do, we have x squared and x. I'm going to choose the one with the higher power, so in that case this would be x squared. And then the derivative of that, du, is just 2x dx. Now what I'm going to do is solve for dx by dividing both sides of this equation by 2x. And we get to dx is equal to du over 2x. So now I'm going to substitute the variables that we've found, u and dx, into our equation. So we're going to have the integral of e to the u times x, and then dx becomes du over 2x. Now this is why we solved for dx, because what it did was help us cancel out that last x that we have. So what we're left with is the integral of e to the u times 1/2 du. And what we can do is pull that 1/2 out in front of our integral and deal with it later. So we'll just be left with 1/2 times the integral of e to the u du. Now, if you're familiar with the derivative of e to any power, you'll know that the integral of e to the u is just e to the u, right? So our answer is going to be 1/2 e to the u. And then since we're doing indefinite integrals, we have to do that plus c at the end. But we're not done just yet. What we want to do is put our answer back into terms of x. So we have a u right now, and we said that that's equal to x squared, right? So this is just going to become 1/2 e to the x squared plus c, and that's our answer. Now let's look at another example. What if we wanted to find the integral of tangent x times secant squared x? Now this one is actually very simple to do if you know your derivatives of trig functions. Because you know that what we should do is say that u is equal to tangent x. And we're going to say that because du is going to be equal to secant squared x. And that's dx. And that's every part of our original equation. So in this case, there's no need to solve for dx because everything is going to work out fine without doing that. So let's start substituting. We'll have the integral of u du. And that's it. And this is a very simple integral to solve. We know that this is just going to become u to the 1/2 power. Oh, not u to the 1/2 power. I apologize. U squared times 1/2. That's where I got confused. So 1/2 u squared. And then plus c. Now, like we said, we're not done yet. We have to substitute our value of u back into the equation in terms of x. So we get 1/2 times u is equal to tangent x, so tangent x squared plus c, and that will be our answer. Let's look at a couple more practice problems. Say we want to find the integral of x squared times a square root now, 4x cubed plus 7 dx. Well, again, let's set our u equal to our highest value of x, our highest power of x. So we'll set that equal to 4x cubed plus 7. Du is therefore going to be equal to 12x squared dx. Let's solve for dx and divide both sides by 12x squared. And we'll get that dx is equal to du over 12x squared. Now we can begin substituting. So we'll have x squared times the integral of u times du over 12x squared. And again, this is why we solve for dx, because it helps us get rid of that last x we have. X squareds cancel each other out. And now again, what we're going to do is pull 1/12 out in front of our integral. So we'll have 1/12 times the integral of the square root of u du. Now all we need to do is evaluate this integral. Now square root of u is just another way of saying u to the 1/2 power. So we're going to do our reverse power rule. And what we're going to end up with is 1/12 and then the reverse power rule. So we're going to raise the power by 1, so u to the 3/2 power, and then divide by that new power, we get 2/3, right? And then plus c. Now let's multiply out 1/12 by 2/3. That's going to be equal to 2/36, which reduces to 1/18. So this becomes 1/18 of times u to the 3/2 power plus c. And finally, substitute our value of u back into the equation, we get 1/18 times 4x cubed plus 7 to the 3/2 power plus c. Very complicated answer, but very simple process. And now let's look at our last problem, and hopefully you'll understand how to do this by now. We're going to do a fraction. We're going to say we want to take the integral of x to the 4th over x to the 5th plus 5 dx. So let's set our u equal to x to the 5th plus 5. The derivative of that is just going to be 5x to the 4th dx. And finally, let's solve for dx for the last time, and we'll get that dx is equal to du over 5x to the 4th. Let's start substituting. So we'll have the integral of x to the 4th over, we said that this is equal to u, and dx is equal to du over 5x to the 4th. And for the last time, we see how this helps us cancel out our x's. And what we're left with, right? Here, let me write this out. What we're left with is the integral of 1 over, here, let's see, 1 over 5u du. So we could pull that 1/5 out in front of our integral and get 1/5 the integral of 1 over u du. And now, if you know the derivatives of natural logs, this is where knowing the derivative is important, because now we're doing the opposite. So if you know that the derivative of the ln of x is equal to 1 over x, you will know that the integral of 1 over u is going to be equal to ln of u. So we'll have, our answer is going to be 1/5 natural log of u du. And then what we want to do is substitute our u in terms of x variable. So we'll have 1/5 times the natural log of x to the 5th plus 5th plus c, since indefinite integrals. And that is how we do our u substitution using indefinite integrals. If this video helped you and you made it to the end, thank you. I really appreciate it, and I hope you learned something.